Okay, this video is for e-learning assignment number 3 for Geometry Basic. That's for Monday, March 23rd and Tuesday, March 24th, depending on whether you're on the AB schedule. What we're working on is pages 7, 8, and 9 in the note packet for this assignment. This is the top of page 7. And what we're trying to do here is we're trying to provide an estimate for how big this arrow is based on the blocks. Just like on the front page of the note packet, where you count up how many squares are in the fish. In this case, we're trying to count the squares. Now, there's a little bit of a problem because not all the squares are full, and that leads to 2 different approaches. But first thing you do is start counting the obvious ones. This 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 full squares. Now, what about all these partial squares? Well, there's 2 basic ideas here. What most people will instinctively do is they'll start grouping those squares. They'll say this one plus this little bit sticking out of this one, that should count as 1. So they might count this as number 11, and likewise this one is number 12. And the same thing over here on the left. They see this square with these 2 little bits sticking out of these other squares. That might be 13, and same way this is 14. Now, this is only an estimate because you're not counting, if you do this, all these little bits sticking out of these squares up here. And so instead of saying 14, you might say the answer is 15, because if you count up all those little parts, that might count as 1 more square. So it's only an estimate, so your answer would be either 14 or 15. Now, instead of doing it that way, one of the faster ways to do it is what people do is they count squares that are more than half full. So all these squares in the middle that are completely full count. This square is more than half full. This one's more than half full. Store these 2 on the ends, but all these little ones don't count. So you have a couple different ways to estimate the area of a shape on a grid. I want you to do the same thing with problem number 2 and provide an estimate for what is this area. You don't have to be perfect. You just got to be close to the right answer. If you're within 2 or 3, you'll be fine. So you're going to provide an estimate for the area of this heptagon. For the bottom of the page and the next 2 pages, we're going to use Agile Mind. So you're going to have to log into Agile Mind. Remember the website for Agile Mind, it's not agilemind.com, it's leiden212.agilemind.com. When you get here, go under Courses and select Geometry. Then where to go in Agile Mind is here. Under Geometry, we're going to go to Chapter 21, Modeling with Area, and into the overview. So we go down to Chapter 21, Modeling with Area, and we're looking at the overview of this problem. Now, the first question has to do with what's the area of this rectangle. It should be pretty simple. You know how to find the area of a rectangle, just length times width, and using the numbers you're given. Now, that's assuming that we have that there's no riverbed. That means there's none of this soil down here in the black parts cutting into it. So the answer we get when we multiply our length times width or base times height will be too big, because obviously there's less cross-section of the water here. You can scroll through sections through the first 3 slides to get to slide 4 and come up with a solution for that. So this whole problem, this is a weird analogy, and to understand what's going on, you have to understand a little bit about what a hydroelectric dam is. To understand that, you have to understand what a motor is. A motor is really simple. It's an object, it's a tool that when you add electricity to it, it starts to spin. Well, you can run a motor backwards. If you take a motor and start to spin it, it'll generate electricity instead. It's just the same thing running backwards. And that's the idea behind a dam. You block a river with a wall and put a little hole in the wall, so the water has to basically shoot through that hole really fast. Just like putting your thumb over the end of a hose to shoot it farther. You give it less space to go through, it goes a lot faster. Except in this case, you put a motor in front of it, basically, a motor in front of it, and the fast-moving water spins the motor and creates electricity. When you do this, it's called a generator when we work the motor backwards. In order to figure out how much electricity we can generate, we need to know how much water there is. And part of the calculations here involve figuring out what the cross-section of the water is and then measuring how fast the water is moving through it. And so the idea here, with this problem, is a real-life situation where we need to find an estimate for how much water this is. To do that, you scroll to slide 4. And basically what we do is we overlay a grid over this and we can count this up. Now this grid won't be, if you use this one, it won't be very accurate. However, so in order to get a more accurate estimate, use a smaller and smaller grid. So you can shrink this grid and use this to provide an estimate just like we did in the problems on the top of the paper. So questions 4 and 5 on this page. Question 4, what do we do to get a more accurate measurement? Well, we're going to use a smaller grid to get a more accurate measurement. And in the bottom, question number 5, I want you to shrink this to the smallest possible grid here, and you're going to count up how many squares fit. Now, when you get an answer, you're going to get an answer that's going to be, well, I don't know, however many squares you count up here. And you have to multiply that by this number up here, this 0.063, and then I'll tell you how many square meters is the area of the water coming in. After you finish page 7, we go on to page 8. Now, page 8 is all about identifying how the numbers that we use to find area. And everything that we do when we're trying to find area is some variation on base times height. Area of a rectangle, we multiply the base times the height. So area of a rectangle, just base times height. Area of a parallelogram, just base times height. Area of a triangle, and I'll explain this on the next assignment, is half the base times height. So our formula is 1/2 times base times height. But the thing you have to be able to do first is identify base and height, and that's what these pages are all about. Now, so you log in EduMind, you're already at this point modeling with area. Ooh, I misspelled modeling there. And you go under exploring and sheer mathematical magic, and you can use that to answer these questions on slide 2 here. At the bottom here, we have these problems. The idea here might be a little bit hard to understand, but what we're being asked to do is, if the blue side, it's blue on my paper, it's just a little darker on yours, but if the blue segment is the base, where would the height be? And that's going to be important for every shape we have. So here I've gone under exploring, sheer mathematical magic. I'm going to go to slide 2. And at the bottom, there's these little numbers. We're going to go through them. And so if this is my triangle, if this side is my base, I can click on one of the sides that says that's my base. The question is, which one of these is the height? If you pick the wrong one, well, these two don't make a right angle with each other, so it goes away. But these two do make a right angle. So if I put this in, if this blue side down here is the base, then this red part here is the height. We have to be able to identify base and height. They have to make a right or 90-degree angle. So in these problems on the bottom, you can use EduMind to help you, but with the highlighted side, I'm going to ask you to draw in the height given this base. The problem I just did was this one, where if this bottom part down here, if that's the base, then this would be the height. So it's something that you would draw in your pictures on the bottom here. They have to make a right angle. So you should be able to finish this page. This is page 8 in the note packet. And finally for this assignment on page 9, it's kind of the same thing. Here I have a triangle. I have a whole bunch of different bases, and we're just trying to identify the height. If the base is segment BC, then what would the height be? Well, segment BC is this length down here. So the height, the side that makes a right angle with it, would have to be this one. You can use EduMind to help you through this. It's on the next slide here where you can identify the proper height. Remember, your base and your height have to make a right angle. You can use this to complete page 9. And that's the end of this assignment.